Well, welcome back. This is Bill Foote. This is Stats 1, and this is Lecture 8. But now we're in Part 2. So we actually build the thing that we started to talk about. Remember, we have 4 regional vice presidents and 6 product management vice presidents. And there it is. It's ready. And we have some data, and they have a question. The organization has a question. What is quarter 5 going to look like? We have 4 quarters of data, and we built a little wireframe, and we're going to do the same thing here. The data looks like this over here. See that in a half a second. And one of the other assumptions of our model is we're eventually going to say Gaussian. Robots go mad now. It's count data. It's sum of transactions. So we'll start with just a 2-parameter symmetric observational plausibility model. That's what we're going to start with. But here's the wireframe. We're going to put that together right now. So let's pull up a sheet that has the data in it. And here it is. And the first thing we do is we take this data and make named ranges. See, I'm using create. Don't want the left column, which happens to be non-numeric data, only the top row. This is all metadata, the names of the rows. And we check over here in the name box and see we have count. Yep, that works. Okay. So thousands of items. The second thing we do after named ranges with data like this, and this is a very, what I call a very, very flat file. It's in column format. This is actually very pivotable, and we can do a pivot table pretty easily with this to get some interesting results. What we're going to do is not use a pivot table. Sorry about that. But we can build a pivot table pretty quickly. And but I wanted to show you how to use SUMIFS in order to create the same thing. Want to use base Excel, hard to break the binding of functions. Okay, pivot tables are another discussion, another time. I go to data for this. There we go. And I choose filter. We see little drop boxes appear. Let me expand this a little bit. There we go. And the drop boxes allow me to do the next thing, which is to say, what does the data look like? Immediately, there are 4 categories. So this is categorical or nominal data. So we have ways of classifying that. Product the same way. And I usually stretch this out so I can actually see the entire cell. That's extremely useful to do. The clients will love that. Product. Oh, we have 6 products. Looks like we have 2 product families, a Lancaster and a Star family or group. And time, 4 quarters. Remember, we're looking for the 5th quarter. And counts. Remember, these are summations. There's a whole bunch of these because they're all unique. Well, they should all be unique. I suspect that if there are same counts in quarters, which is, my God, pop a cork for that. What are the odds? That listing would have 1 or 2 less than what the actual number is. Okay. We can do all sorts of other things with this data immediately. But what I want to do next is create lists of each of the region, product, and time. This will allow us to slice and dice the data at some point in the future. going to make another spreadsheet called control. That's what this has been called for years. And notice it's capital REGION. So I'm going to use lowercase regions. And I'm going to say region underscore name, just so it doesn't ever get confused with region. I'm also going to have product underscore name. And the third thing I'm going to have is time underscore name. This is what is called camel format. The camel format? No, snake format. Yes, snake format. Camel would have a hump in it. Camel format would look like this. Time, capital NAME. Okay. So anyways, coders. And the regional names will be equal to, and this is referential integrity. We have East, pull it directly from the data. And we want to go back to data. North. Now there are clever ways of doing this. I'm just hacking my way through because that's what I do. There are a million ways to do everything, of course. Not a million, but quite a few ways. Okay. And exaggeration there. Equals. Oh, west. I think we have 4, right? Now, these are all I'm going to need right now, and we can build the rest as we go along. It's always a good idea to make it visually easy with all borders. Okay. Now, the other thing I'm going to do is I'm going to take this regional name and I'm going to put it into a named range. There we go. And we can do the same for product and for time. And now we have region, but we have region name. And there it is. Now, why is that useful? Create another sheet. We'll call this analysis. This isn't the dashboard yet. The dashboard would take whatever is in the analysis and put it into a separate sheet, referring back to the analysis, into a separate sheet, and then format it. So then again, the consumer of this intelligence now, intelligence is because we have used various activities to shape the data, associate the data, provide user interactivity with the data. This is the provision of understanding. Now that interactivity, then we can visualize that. We can see if we choose those different regions, things change. That's where we're going to want to go when we get to count and infer. Okay, in this upper box here at A1, typically we can, old school would have you put an apron around this and create a region. We don't really need to do that anymore. In A1, we're going to only allow certain values in that. So we need to go to data and hunt and peck for this, but it's usually over here in data tools. And here it is right here. I'm squinting into it again. Data validation, just click on that. And we don't want any old value in there. We only want very specific values. As a matter of fact, a choice from a list. And the list is equal to region. Oops, region, not choice, region name. Okay. Now it's unfortunate that Excel does not yet allow this dialog box to know what the named range is. I'm sure there's a wonderful reason in well under the hood. There we go. And we just check this out and say that, here are our regions, choose one. Okay, now we have one in there. Also put a box around this. And I'm going to put a big box. Very dark. Okay, so I can see it. There we go. You can see it. Now, I said, don't put anything into the control. Well, we're going to need it. And this is why we're going to need it. We want this analysis report directly from the data. So across here, we're going to put the 4-quarter names. Down here, we're going to put the 6 product names. Okay, well, we need those names, and we're going to control those names. We have 6 products, and let me show you where I'm going to get those from. Equals. Here's the products. Let's go up here. It's pretty easy to do. We take a Lancaster. That's one product. We get the second Lancaster. It's Lancaster L. And the third Lancaster XL. Oops. Here. Ahead of myself. Because you're going to want to automate this process. And then we do the same with star. Star 2000, wonder what that is. Star 5000. And I think we have a 9000. Okay. And of course, we're going to make that a named range as well, because we'll be referring to that in a nanosecond or two. Check it out. And we have product names. Beautiful. And we also get time names. This is, of course, Q1. I think I can just do this. And I do. Okay, so that made that eminently easier. Of course, I'm going to make this into a named range as well. That allows us to understand what is becoming a little bit more complex a operation here. Okay, and there we go. Okay, now back to the analysis grid that we're making. Well, product is pretty easy. We just go here equals whatever is in control. Okay. 2, 3, 4, 5, 6. Okay, remember, I'm hacking this together. Span this column. Let's do a little bit of, I think I want to make that bold so I can see it better and center it. And I'm going to write justify these. Again, just to make it a little bit easier. And we can also consider, and now different people have different ideas about what I'm going to do next. Okay, I'm going to put a grid around that. Let's open this up a little bit so we can see it better, because we're going to have an interesting formula coming up. Now, we've all learned a little bit about arrays. Arrays have rows and columns. We have a column of names called quarters. We need to put it into a row. Excel and just about every spreadsheet program on the planet now, can do this. Select the 4 cells that we want to deposit a column into this row. Those are the 4 cells. The way we do that is equals transpose. Well, that's what transpose means in matrix. The shaping part of matrix manipulation in algebra. And actually, I can put in here time. Whoops, not there, of course. There, where that cursor goes. Time underscore name. See, it is something that the system knows. And I always like to put spaces around. Now, both hands off the keyboard. Okay. What we need to do to make this take each and every element of that column of names, Q1, Q2, Q3, Q4, and put it into this row, to spread it across, we now press Shift, Control together, and then Enter, and voila, it happens. All right. There and there. Now we've done that. Okay. Now, in these boxes, we want to locate the Lancaster and Q1 numbers. Now, there might be multiple. I don't know. I don't know how this system works. There might be multiple for whatever reason. I didn't write the SQL code to pull this data from the systems that carefully guard, steward, and govern this information. So I'm going to use SUMIFS. I'm going to sum all the instances of East Lancaster Q1. Well, where would that be? It would be this data right here. We should see 40, 42. And I'm pretty sure that's the only instance of it. But if there were other instances, we would be able to pull it up. Okay. Well, we got to be always worried about double counting, over counting, under counting. Yeah. So equals SUMIFS. Make sure you have that S in there. And the first thing it's looking for is, what are we going to count? Now, if there's only one of these will appear, the sum of one item. Okay, that's pretty easy. The next thing we're going to do is specify the region, comma, double quotes, if region equals, and double quotes, equals, ampersand, equals East, right here. And what we have to do is, I could make that region choice, for example, instead of A1. Okay, that would be a nice way to do this. But in this report, it's okay. Well, no, it's not okay. Let's do that. I'm going to actually name this range. Yes, I am. And it is, get back up there, formulas, create from selection. And there is no selection. Oops, define name. And I'm going to call this region underscore choice. Did I spell that correctly? Looks like I did. Let's pop that in there. Okay. Now we have region choice, which is this East right now. Okay, now let me go ahead and do this. Equals SUMIFS. What am I doing? I'm doing count. Okay, I'm summing across the counts. Only if region, comma, equals, oops, not plus. No. Where's my equals? There we go. And that has to be in double quotes. Concatenate that together with region choice. See, it changes color. It knows it's there. Well, what else are we going to do? We're also going to do product, comma, equals, concatenate that with Lancaster. Now, if you don't do this, this will fail. You must put a delimiter called dollar sign that holds constant, absolute, that part of the address called A. A are the columns. It always has to refer to that column. And we're gonna let it schmooze over, fan over all of the quarters. That's the 2 and the okay for with each of the quarters and down each of the rows. And the next one is time equals, and well, we can't see it very well here. It should be in B1, but here this time we want to hold the row constant. We want to make sure we have all the quarters in there. These names are critical, and this is the whole issue of referential integrity. It's referring to a piece of data that the system will recognize inside of the original data set, and it will sort it out. It will pivot it, and this is a pivoting operation. Well, why don't we use pivot? Like, you go ahead and use pivot, all right? But I like this because when I have built larger systems and I have to change the row names for any reason, I have dynamic row name changes because the user wants that. Pivot tables tend to break, and you have to repair them. You have to create a whole set of routines to repair them. Table manages that to some extent, okay? But again, I'm using much more basal, raw Excel here. Table would be a good way, and slicers are also very good. So we're going to do this and cross fingers. There we go, 4042, exactly what we need. Spurred on by that success, we move this over and down using keys, shift right, shift down, control V, and we have all of those. Just check one of these for a different, say the north, Lancaster Q1 should be 3348. Okay. And it is. Okay, a spot check is useful. You never know. And I'm just going to encase all of this into a single big box. Again, I can format this in very clever ways. We haven't even gotten to our observational model yet. How would we do an average? Pretty simple. We can do an average here equals average across the quarters. Averages have a wonderful quality. And what is that, 0.5? Well, yeah, we could do that, but let's reduce that. All of these numbers. There we go. And I'll probably put that in the box. There we go. See, the averages are pretty close. We can also do standard deviations as well. Just use the original standard deviation. Probably a sample. Do it like this for the quarter. Again, make this a number, and because these are all counts, much easier to read, put it into a box, copy, cross. You can do the complete average. Yeah, there we go. Cross everything. Okay. And you can do the complete standard deviation. And I'm correcting for degrees of freedom, because we like to do that. Now, some of the standard deviations will not, these standard deviations don't add up. It's a property. Standard deviations were that 1497. It's not the average of any of these, okay? And it's not the standard deviation of the standard deviations, which, by the way, is kurtosis, or some variant of that measurement. But if you look at the average of these four numbers down here, you will see average is 4781. Yep, sorry about that. 4781. Yep, it's the same as that average. That's a different property. Okay. Additive. This is sub-additive. Okay, that's math. Yes. Average. Can't write right now. And these will be on each row. Row-wise averages. And row-wise standard deviations. We want to make these two into numbers and lose the decimal place. And also the borders, Control C, Shift down, Control V. And you also see that the quarter standard deviation is going to be quite different from the variation in products. That's an insight. Products across quarters for each product is going to have a different order of standard deviation, which is fascinating, as opposed to across products for each quarter. But that makes sense. I mean, that's 200. And it's how tight this is, not very tight, not very tight, but across products, a wide variation. So that's something you can report as a result, if you like, a bit of insight into the data, that product by product variation is different from quarter to quarter variation in products, which means that the risk profile is different across products as opposed to cross quarters. Okay, and it's 1497. Well, we also need, that's across everything. That's correct. But notice it's not this way. Okay, whereas this 4787 is the same 4787 here as it will be here, because it's just simple counting. And as for the north, now that we have all of this, we can see what it looks like to the west. Or the south, depending upon who you are. Now, you can also, over here, put summaries of, for example, for each one of the regions. And for example, you can use average if. There's also average ifs. Now these are relatively new. And the range criterion will be region, comma, equals east. And we are going to be going over count. Now notice the syntax of this is different. Notice we have the 3676 there. Okay, that's the south. So this number will always tie up with that number. So you can also build summaries over to the side and do the same with products. Very, very simply. Their products. Not going to do averages again. You can also do sum if to get the full count too. I'm just going to borrow this formula here. And of course, it doesn't know anything about region there. What we need instead of region is product. There we go. And these are averages of products in the data across all quarters. And again, if we can't get that from this table, by the way. We cannot get that from this table. We would get it from a table. If we had South, we would use Lancaster there. If we had Lancaster, then each of these would only be 4 regions here across the 4 quarters. And then we would be able to tie that all off. Okay, so these would be average. And let's just tidy it up just a tad. Leave it at that for the moment. Okay, hope this was useful. And I think we spent more than enough time doing this. But we have the beginning of formulating our hypotheses. We still haven't done anything about what is quarter 4. Is quarter 4 for Lancaster going to look like the average and the standard deviation? It might. Okay, if life continues the same way. Okay, so we can see how that operates across different averages, different standard deviations, a low and a high standard deviation. For example, this is a pretty low standard deviation. Here's a really high standard deviation. So a 100 and a 900, yeah? And different averages, 4 or 5 different averages, and we check that out. And we have done this before with the Gaussian model to figure out the plausibilities. So that's going to be our next step in another part of this series coming up soon. I hope you found this useful. And as always, I thank you for your very kind attention as I return you to your regular duties. Till later, thanks, bye.